It's time to implement our empty dispersion storage. In previous episode, we implemented our dispersion storage. However, we have this instance that needs to be implemented. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. To implement our empty dispersion storage, we need to first implement our single dispersion storage. Now, a single dispersion storage is a storage that carries a single type of dispersion. To implement it, we extend it from single variant storage of type dispersion variant. Of course, we will have a notification later, so let's fix it. It says notify this as not null. Let's do that right now. I'm not gonna implement all the methods because this is an abstract class. Other storages will go and use this one as the base. So normally we won't have a single dispersion storage that we can add to an inventory directly. However, this is the base that we'll use for different type of storages. Let's say public static single dispersion storage as the return type with fixed amount. We have a long capacity and runnable as the on change. Now this one will be used when we want to have a single dispersion storage with a fixed capacity on change. If you ever used any one of the Fabric API or Energy API components, you have a method that says on final commit, and then we override it and do our own things. Here we want to create a method that actually returns such a thing. So we say storage preconditions dot non-negative capacity. This is a helper method that comes from Fabric, I think. Yes. And it checks that this capacity shouldn't be a negative number. If it is, then it will throw an exception. Then we say objects dot require non-null the on change. The method that we are sending in shouldn't be null. And here we say on change, let's use the lowercase o, may not be null. After this, we can return our storage. So we say return new single dispersion storage, and as you see, we are implementing an inline class that we can use now. Let's go for the things that I know what I do with, for example, the capacity and on final commit. Here we will say on change.run. So anything that we send in as the final commit method, we will run it here. Now the only thing that remains is this get blank variant. Cut it from there and come out. And right now, we will have an error here saying that, hey, you need to implement a method. That's okay, because right now, after this method call, we will implement that one. And here, we want to return the dispersion variant dot blank. That's our blank method. Because we write it here, we don't need to override it here. Then I want to have two methods, public void read data that accepts a value input, and we call it view, and then a public void write data that accepts a value output, we call it view. Now, if you ever used Minecraft before these versions, you know that we had something called NBT, and that was the data that we would store on the hard drive and retrieve it between the saves and loading the game. These two methods are responsible of reading and writing those data. However, in the newer versions of Minecraft, it's not called NBT anymore, and the whole concept is changing around this value input and value output. Now, to read the data, it's easy. We say single variant storage dot read value, and here we want to give the class, and then the variant is dispersion variant dot codec. That's our codec. Then we want the fallback as the default value, so that's the dispersion variant colon blank. And finally, the view as the thing that we should read it. For the write, it's again the same thing, single variant storage write value, again this, and then the codec is dispersion variant dot codec, and finally the view. These two methods will use the codec to read and write the data automatically on the hard drive, so we don't need to deal with the hows and what to do anymore in the API, because before few versions ago, we had to handle many things ourselves when it would come to serialization, reading and writing. However, these days, If you are defining a base storage class, you just read and write using the single variant storage. And that is our single dispersion storage. Now we can go for the empty one. This one is really easy because we extend from the single dispersion storage. We are not abstract, so it asks us to override some things. But before that, we say public static empty dispersion storage, and let's make it final. We call it instance equals to new empty dispersion storage, and that's it. However, now we need to override many methods. For example, get capacity, that returns 0, insert, that will return 0 instead of calling the super or doing anything. Extract, again, we will return 0 there. Remember, this is an empty storage. It shouldn't do anything. Get amount will return 0. Supports insertion returns false. Supports extraction returns false. And that is our empty storage. Now, normally, you wouldn't use empty storages inside your mod unless you want to do some testing or things like that, or as a creative item, I don't know. However, as you noticed, in our dispersion storage, we have this empty as a storage, and we did use that instance there. So where will we use this dispersion storage.empty is when we define something and we want to fill it with empty storages. Other than that, because it is defining the insertion and extraction to be not supported, it really has very limited amount of practical usages, but it should be there because as an API, you don't know what people want to do. And when you're designing your API, you should think about many different use cases that even you are not thinking about them. Now, what's wrong here? It says annotate as not null. Okay, annotate as not null. And that's it. In the next video, we will come back and continue with our other storages because we did cover 3 of them. And as you see, we have this empty item dispersion storage, full item dispersion storage, and these are just the base storages. After that, we can work on our stack payload. After the stack payload, finally, we will be ready to write our connector, our block entity, our storage connectors inside block entity, and the things that we had seen so far in other implementations. Have fun, everyone. Bye.